R, which I told you we're going to be using combination to do binomial distribution. Success to power R and failure to power n minus R. That is the formula for binomial distribution. So I'm actually given everything. The question I'm given is exactly, so whenever I'm given that the random variable is equal sign, it means the random variable, means the question is exactly. So one single binomial distribution. So I can as well use this formula here. So I will plug in. The sample size is 8, so 10. So 10 combination 8. Success is 0.85 multiplied by 0.85, 0.85 to power 8 multiplied by the difference between 1 minus 0.85 is 0.15. So failure is 0.15 to power 10 minus 8. 10 minus 8 is 2. So actually, if I evaluate this by hand, I'll get the answer. But really, I don't want to evaluate it by hand. But guess what? If you evaluate it by hand, you get the answer. 10 combination 8 multiplied by 0.85 to power 8 multiplied by 0.15 to power 2. Either way, any way you do it, you get the answer correctly. So I'm going to use my calculator. Let's see where my calculator is, right here. So I'm actually going to do the multiplication here. I'm going to do the multiplication. So I can just do 10 combination 8, 10 combination 8. Remember that combination is a mat, arrow to P, arrow B. And combination is number 3. 10 combination 8 multiply, and I can just say answer, enter. Then multiplied by 0.85 to power 8, 0.85 to power 8, that's caret 8. And I get an answer. Then multiplied by 0.15 to power 2, multiplied by 0.15 to power 2. Then I get an answer. And so the probability, and by the way, this is combination. So our answer is really large. So the answer is really large. So I want to do this by calculator and see. Do I get a large answer like that? So because remember the binomial is a probability. So what I'm going to do is go to my binomial P. See, in binomial, let's go to math first. So second distribution, and we select binomial. So we are arrowing to binomial. Because it's a binomial PDF, which is one single probability, I'm selecting binomial PDF. The number of trials is 10. Probability of success is 0.85. The probability of, the value of the random variable is 8. And then I'm going to paste my answer. So that probability is 0.2758, depending on the number of decimal places. So I'm told to round to 4 decimal places. In other words, to the nearest 10,000. Therefore, the probability is 0.2759. So that probability of 8, which is called P8, is 0.2759 to the nearest 10,000, 0.2759 is that probability. Whenever you solve a probability, if it's binomial, if it's binomial or discrete, and you solve it and your answer is greater than 1, then you know something is wrong. You have to do it again, use another method. Okay, so the probability is 0.28 because we said that all probability distributions must obey the laws of probability. So the probability cannot be greater than 1. It has to be almost 1, cannot be greater than 1, and it cannot be negative. Remember, I want to write the probabilities again. These important rules of probability. Number 1, I write it every day. Sum of all the probabilities of any event must be equal to 1 exactly. Number 2, the probability of an event has to range from 0 to 1. Cannot be more than 1. Cannot be less than 0. So we said this. I want to make sure that we say it again. So that is number 2. So we're going to find probability questions and solve. Make sure we solve about 2 or 3 of them. Okay, or I can actually use number 2. This number 2, let me rephrase this question. I'm going to rephrase question number 2 so that I don't have to run around so much. Okay, so I'm going to rephrase question number 2. I'm given this question as an exactly question. So there are 3 important ways you can be asked a question in binomial distribution. It can be an exactly question, like this number 2 is. So number 2 is an exactly question. So question number 2 is an exactly question. So question number 2, I will call it A. It can be exactly, and if it's exactly, then it's binomial PDF. Binomial PDF. Binomial PDF. I forgot to put the Clemson thing. Let me get it and put it in here. Okay, let me get that thing from Clemson so that, where is it? All right, I found it. Found it. All right, so, okay, so I'm just going to pull the stuff up and put it in here. Somewhere here. Okay, so, and then I'm going to pull up everything. What will now convert your PDF to an editable Word? Okay, so I am about to go back to this. Okay, go back to this. What? Come on. You have to obey the rule. Okay, so we just answered an exactly question, but I'm going to say, suppose it's not equal sign here. Suppose I am given n is equal to 10 and x is less than or equal to 8. In other words, I'm trying to find the probability of from 0 to 8. And what does it mean? So I have to find P0 plus P1 plus P2 plus P3 plus P4 plus P5 plus P6 plus P7 plus P8. Okay, what in the world is P0? Okay, so I'm going to make sure we understand what P0 is. What is P0? What is P0? So let me come over here and write it. If I'm told to find P0, P0 by formula is 10 combination 0, 10 combination 0, 10 combination 0, success to power 0, success is 0.85, success to power 0, and failure 0.15 to power 10 minus 0, which is 10. If I evaluate it, I get P0. That's equal to P0. When I'm told to find P1, P1 is 10 combination 1, success to power 1, failure to power 10 minus 1. 10 minus 1 is 9. That is P1. P2 is the same as 10 combination 2, success to power 2, failure to power 10 minus 2 is 8, and so on until I get to P8. And I'm expected to find P0, P1, P2 to P8 and add all of them together. But there is another way you can do it. That's a simpler way you can do it. So I'm going to use that simpler way. So instead of finding them differently, I can find binomial CDF. So I'm going to find binomial CDF. So I'll find binomial CDF, binomial CDF, cumulative density function, sample size, success, and the number 8, random variable. And this actually means that I found from P0 to P8. That's what it means. From P0 to P8. That's what it means. If I add all of them, so P0 to P8, and my answer. So the total of all the probabilities, it is easier. So whenever you are told to find the probability of a random variable, x is less than or equal to maybe 8, it is easier to use binomial cumulative density function. So this is the method I'm going to use now. Because if I do it one by one, it means find P0, P1, P2, P3, P4, P5, P6, until you get to P8. So it's a waste of time. Remember, on the test day, which is on the 30th of this month, you will have 20 questions to answer in 90 minutes. So you cannot be answering one question for 30 minutes. You have to make sure you have the speed and the accuracy. You know how to use your calculator. So I'm going to substitute now binomial cumulative density function. The sample size must be given to me. It is given 10. Success is given to me as 0.85. And the random variable is 8. You see, it's random variable, so it has to be an integer. So I'll pull my calculator up again and put it in binomial CDF. I will show you how to find binomial CDF. So go to my calculator, and I'm going to clear second distribution. I'm looking for binomial CDF, binomial cumulative density function. And that's what it is here. I'll pull it down. Number of trials is 10. Success is 0.85. the random variable is 8. Therefore, I will go to calculate. Therefore, that probability is almost to 1. That probability is almost to 1. But before I conclude it is 1, let me go to my mode and set the mode. So that probability is almost to 1. Not supposed to be 1 though, but almost 1. So I used all the, so we said the probability is approximately 1. All right, so it's a very large probability. Okay, cannot be greater than 1, so that we can take this answer. What is, if I'm told to find the probability, see, I'm changing the question again. What if I'm told to find this probability? What if I'm told find the probability that the random variable x is greater than or equal to 8? And what does it mean? It means find P8 plus P9 plus P10. That's what it means. Another way you can do it is find the probability of 1 minus P9. Because if 8 is included, you cannot subtract it. So find a number that is greater than 8. So this is an at least question. So now you do binomial CDF. Then you come down here and put in sample size is 10, success is 0.85, and the next random variable is 9. So you're only going to look for 9 and 10. So I'm just going to get my calculator. And calculate the binomial, the probability that the random variable is greater than 8. So 1 minus binomial CDF, so second distribution, binomial cumulative density function. And this is 10, so this is 10. Sample size is 10. Success is 0.85. The value is 9. And I'm going to paste. So I just told my calculator that the number of trials is 10. Probability of success is 0.85. And the value of x is 9. So I'm going to calculate again. Therefore, the probability that the random variable is greater than 9, that's greater than 8, which is something as 9 plus 10, is 0.1969 to 4 decimal places, to the nearest 10,000. So we have answered that question. So there are maybe 3 or 4 cases. Case number 1, when I have an exactly question, then I use PDF. When I have the probability of a random variable less than or equal to, then I use CDF, accumulated to the left. But if I am given the probability that the random variable is greater than, the probability is greater than the random variable given to me, then I'll use an at least. At least means 1 minus binomial CDF. So I use at least to answer that question in any binomial distribution question, and you are told to find the probability of greater than or equal to. It's an at least question. Now, whenever you're given an at least question, you do 1 minus complement, the complement method. Okay. Oh, well, they can actually ask me to find the probability of between. I could be asked to find the probability that the random variable is between 5 and 8. All right, what is the probability of that I'm getting between 5 and 8? So that is between. So I'm going to actually write it. So altogether I have P0, P1, P2, P3, P4, P5, P6, P7, P8, and P9, and P10. These are the possibilities. But the question is asking me, what is the probability that random variable starts from P5 to P8? So I'm only supposed to find P5 plus P6 plus P7 plus P8. I can find them individually if I want to. Can find them individually. Remember that P5 is equivalent to 10 combination 5, success to power 5.85 to power 5, failure 0.15 to power 5. And P6 is the same as 10 combination 6, success to power 6, and failure to power 10 minus 6, which is 4. And then P7 is equal to 10 combination 7, success to power 7, failure to power 10 minus 7, which is 3. And then P8 is 10 combination 8, success to power 8, and failure to power 2. So when I finish it now, I have to find this probability, add it to probability P7, add it to P8, and get an answer. All right, I can do it then one by one, or I can actually combine them. So I'm going to combine them. So it's just going to look like this. Let me, so it's just going to look like this. I'm going to use density curve to represent what I mean. I am going to use density curve to represent what I mean. So if I can represent binomial distribution in a density curve, then I am told to find from P7 to actually from P5 to P8. In other words, I'm only told to find area between. So for me to find area between, for me to find area from here to here, area from here to the end, I have to find at most 8 minus 4. At most 8 starts from here to go to the end. Because 5 is included, I'll subtract the number lower than 5. So actually, if I write it, I have the probability of 5 is less than or equal to probability of X is less than or to P8. Anyway, the important thing is that I have to accumulate. So right now, I'll put my calculator up. So now that I know what I'm going to do, I will find P8, subtract P4. So I'll do that. because when I do that, I have found P5 plus P6 plus P7 plus P8. Okay, so I will get my calculator. In other words, I'm going to be using binomial CDF. Okay, so binomial CDF for 8. So second distribution number, I'm looking for binomial CDF for 8. 8 is included. I get an answer minus, I'll go back to binomial CDF again, and then I will find the probability of 4. Why? Because 5 is included, so I cannot subtract 5. So I must subtract a number lower than 5. And because it's a random variable, I have to subtract a number, not a decimal. So, and then so the answer, the probability between 5 and 8 is 0.4543. So, in other words, in binomial distribution, I can be told to find the probability of exactly. You can be told to find the probability of exactly 1, exactly implies binomial PDF. Number 2, at most binomial distribution of a question is the same as binomial CDF. Number 3, at least binomial question implies 1 minus binomial CDF of the random variable. You have to subtract 1 random variable here. If it is P8, then you will not subtract 1, you just add 1. Depends on, okay. So you are subtracting the, it depends on what you are told to do. Okay. If you are told to find between, then it is binomial CDF of the first one, B, binomial CDF of the first one, B, minus binomial CDF of the other one, which is C minus 1. Okay, so if you do an example from the book or using the author's video, you will see what I'm saying, binomial CDF and binomial PDF. Okay, so these are the kind of questions you will see in binomial distribution. So actually, we need to go to normal distribution because we have binomial and normal today. Okay, so let's see. So I am going to the question now. I'm going to pull up. We'll go back to normal because in this unit, we actually have a whole lot of things to do. So let's go to, we are going to chapter 7.1. We review our normal distribution. We already know normal distribution, but we're going to go back and review. So I'm going to pull up normal distribution question. Where is it? Okay. I'm going to clean this one. So for now, we will come back to binomial later on. For now, we're going to quickly go to normal distribution. Okay. All right, so I am going to pull up a normal distribution question. I'll pull up a normal distribution question that I have here to try to answer the questions. We will actually use, let's start from number one so that number one says, this is normal distribution, chapter 7. For numbers 1 and 2, draw a normal curve and fill in the values for the mean, plus or minus 1, plus or minus 2, plus or minus 3 standard deviations. Okay, so that's easy. So we're going to pull up that question. Let me see what kind of, so this is actually odd problem. So why is it that this is not, okay. Let me see if I am to use my, all right, so let me use my whiteboard since this is not coming out. So if I'm told to draw a normal curve and show so I'm going to try and draw a normal curve, and I'm trying to, they told me to show, this is the mean is the line of symmetry. The mean divides the normal curve into two congruent parts. Well, remember from unit 1, area under the normal curve is 1. Area under the normal curve is 1. Okay, according to empirical rule, the area between plus or minus 1, minus 1 plus 1, that area is 68. According to the empirical rule, that's 68. 68% of data lie between plus or minus 1. According to empirical rule, 95% of data lie between, so I'm going to put it up here, so 95% lie between plus or minus minus 2 plus 2 plus or minus 2 standard deviations. And according to empirical rule, 99.7% of data lie within plus or minus 3 standard deviations. So we're going to draw this one right here. So 99.7% lie within 3 standard deviations. Within means plus or minus. Okay, one thing I want to say is that if this normal curve is drawn like this, then it's called a standard normal. It's called a standard normal curve. A standard normal curve. So whenever you use a drawing standard deviations, this is normal curve. Remember that if you standardize, the mean is 0 from unit 1. So this is 1, this is 2, this is 3. This is minus 1, this is minus 2, this is minus 3. So we call this one the standard normal curve, standard normal curve. Standard normal curve is drawn with within standard deviations, standardized. So this is a standardized normal curve. So let's try to answer this question now. The question given to us here is not actually standardized. Question given to us is not standardized. So let's see how we answer that question. All right. So a dog says this is a dog's lifespan. Dog's lifespan. Let me see. Why is this not normal distribution? Why is it not showing? If I save it as, is it going to help? Save it. Normal distribution 3A. See if it's going to help. Save it. Does it help? No, it's not. It's not gonna. If we can just if it's going to help, that's fine, but it's not helping. All right, I'll take this away since you are not. Okay, so now I will draw another normal curve. So I'm just going to draw a normal curve, and let's see, this one is going to write. Well, it's writing, so let me use the. So let's see if I use another color. What other color can I use? Let's see. Color. Anyway, that's the only color. But anyway, so this tells me that a dog's lifespan is normally distributed, and the mean of that dog, of the that set of dogs, is 12.5 years. The standard deviation is 2. Estimate the probability that a dog's lifespan is between 10.5 and 12.5, 14.5. But the important thing is that the standard deviation is 2 and the mean is 12.5. Mean plus 2, which is the standard deviation, is 14.5. One standard deviation above the mean. Mean minus 2 is 10.5. So this question is actually very easy. Therefore, it says estimate the probability. Therefore, the probability that a dog's lifespan is between 10.5 years and 14.5 years is 68% according to empirical rule, plus or minus 1 standard deviation. So that is really no question. According to empirical rule, we can answer that question. Okay, so let's go to, according to empirical rule, we can answer the question. Let me clean and see how many of them will clean. So we go to question number 2. Let's see question number 2. Let's see if I can minimize this. Can I make it smaller? All right. So now we get to question number 2. The question number 2 says, light bulb. This is about light bulb. Question number 2 is talking about light bulb. All right. So the lifespan of a certain type of light bulb is normally distributed with a mean of 5,000. Wow. So the mean of the light bulb is 5,000. Let me see if this one is going to write. So I'm going to draw a normal curve again. The mean is 5,000. Mean is always at the center. 5,000 hours. And the standard deviation is 150 hours. So one standard deviation above the mean is 5,150. Estimate the probability that this type of light bulb has a lifespan of between 4,850 and 5,300. 5,300 as extra 300. 150 times 2 is 300. So 2 standard deviations above the mean. 2 standard deviations above the mean is 5,300. All right. 4,850 is actually 1 standard deviation below the mean. 1 standard deviation below the mean. So this one here. So the probability Remember that from here to here is 95 divided by 2. So 95 divided by 2 plus 68 divided by 2. If I add these two, that will be the probability. From here to here is 68 divided by 2. One standard deviation below the mean. But this is 2 standard deviations above the mean. So 2 standard deviations above the mean is 95 divided by 2. 1 standard deviation below the mean is 68 divided by 2. We add them up, and we have 8 plus 5 is 13. 10 plus 6 is 16. 163 divided by 2 is 81.5. So the total is 81.5. Therefore, and by the way, therefore the area is 81.5%. The total area between here and here is 81.5%. So we use the empirical rule. It is not all the time that empirical rule work. Empirical rule may not work sometimes. So from unit 1 up till now, empirical rule has been working. Well, right now, let's go to question number 3. Question number 3, does empirical rule work there? See. Let's see if empirical rule work in question number 3. Let's see. Question number 3. Okay, so this time we are told to find the area between the mean when z is equal to 0 and 1.28. So let's first of all draw the picture. So let's draw the picture. First of all, whenever you're given a normal curve question, you have to draw a normal curve. When z is equal to 0, according to what we did in unit 1, it is the mean. So I'm looking for the area from mean to 1 standard deviation point to 8. So this question will not be easily answered by empirical rule. So I'm going to pull up my calculator. This is called area between. So if I'm looking for area between in my calculator, I will do normal CDF, normal cumulative density function. This time it's normal. Remember, we just did binomial. So remember, this is normal CDF. Starting from the lower bound, mean, to the upper bound, 1.28. And the mean is 0. The mean of a standard normal is 0. Standard deviation is 1. So I'm going to get my calculator and put it in. Put all this in. Turn my calculator on. And go to normal CDF again. I'm going to second distribution. By the way, I want to make sure I clean. Let me clean everything. Let me clean before I... Okay. All right. So normal CDF is number 2. Normal CDF is number 2. So I select number 2. And it's asking me what is the lower number. The smaller number is 0, mean. What is the upper number? The upper number is 1.28. So 1.28. And it's not, you can answer this one with, can answer this question with empirical rule. It will take you time. Anytime you can save your time, please do. Mean is 0, standard deviation is 1. I'm going to paste. When I hit enter, the area between 0 and 1.28 standard deviation is 0.3997 to the nearest 10,000. So that area is 0.3997.